preventive maintenance is being important because this is the case of short and frequent so in this preventive maintenance is conducted before the breakdown occurs. Okay. So all of you understand the meaning of this problem? Okay. Let's go to next topics. It's non-preemptive outage. Changeover due to the changes product or the preventive maintenance. Preventive maintenance belonging to non-preemptive because preemptive maintenance is scheduled in advance. The breakdown occurs. Also, any planned break means the launch time or the shift. The break means the break time that the human or machine can have a rest. Or the planned meetings operators. It means that any production process that have to be accompanied by human operators will be non-preemptive status if the operators leave the machines in order to join any planned meetings. Okay, this is the example of non-preemptive outage, and the property of these are the pre scheduled things. So this typically occur between jobs. Can you remember what keyword was located here in case of the preemptive outage? In case of preemptive outage, it was during. Preemptive outage occurs during the jobs. So the jobs in status of process have to be stopped until the breakdown was maintained. And after the maintain or repair work finished, these stopped jobs have to be started again. But in this case means that in case of non-preemptive outage, is occurs between jobs. So in these cases, there is no need to stop any jobs. That is the status of in process. Okay, wait a moment, please. Now we are going to compare two cases. First case is slower and flexible motion without setup. And second one is fast motion requiring periodic Now we are going to compare these two cases. First is slower and flexible motion. Flexible means that the flexible motion is able to various kinds of product. Those require the different production method. There is the flexible motion, but it is a little bit slower than comparing with the fast motion and inflexible. Actually, this second case is the mostly is belonging to the any machine that is specialized to any fixed kinds of work. So now we will assign some value here. Move to here. And in case of the first case, the bottleneck ratio is the 1.5 times A, and the setup time is 0 in this case. And the spec of second motion is like this. So this is the faster than this one. But in this case, the setup time exists. It's 2 hours per 4. This means that every 4 product, every 4 product, the machine, the configuration will be changed in order to manufacture the other kinds of product. So if all the other conditions only except the setup, then the first one is better choice because the variability is reduced. Before this, in this case, the R to the efficient rate, because these two have to be combined. So 6 hours per 4 EA equal and this is actually same with here because there is no setup. It is equal to the natural state of the bottling ratio. So this and this is same. It means that these two machines have same production capacity. However, the second machine have the non-preemptive outage. And this outage will have impact on the variability. So if all other conditions are same between these two cases, the first one is a better choice because the variability will be reduced compared with the second case. And this is the reason why the flexible manufacturing is very famous and sometimes most factories really want to adopt a flexible manufacturing system, even though the price of those machines may be very high. And also, this can be very good reason why just-in-time concept is required, and just-in-time concept require very short setup time. So this gives us a very good reason. First one is the importance of flexible manufacturing. And second one is the just-in-time concept require the extremely short setup time. In the case of very famous the framework of lean manufacturing, and the one of very important concept of lean manufacturing is just in time. And in just in time concept require the very short set of time. And this means that this is the reason why the short set of time is the preferred in the case of lean manufacturing. Anyway, now we have to calculate the actual CV of the both cases. What time is it? Can you give me 5 minutes because I need to review the calculation process. So 5 minutes. In this case means that in this first and second case, there was no consideration of variability of the machine itself. However, if the CV of the machine itself is considered, then we have to calculate. So before that calculation, we have to adopt several the performance parameter. First one is TE. In case of non-preemptive pre-AG, is calculated like this. Firstly, the natural working time, and this is summation of the setup time, and this setup time is divided by the number of setups. And there is one assumption that the setup events are evenly distributed. Time, along with the time. So we can write like this when the efficient working time is calculated. And next is the standard deviation. And in the same way, in case of preemptive base, we will not induce the process of the calculation, the induction process of this formula. We just borrow the result of the pre-survey. And CE square becomes It's easy. So this is the required formula for the calculation of the non-preemptive edge cases. In order to calculate this, we need to define several parameters. The NS is the setup period, and TS is setup time. C is the CV of TS, not TE. CS is the coefficient of variance of TS. Now, using these formulas, we will compare two cases a little bit different from these two. These two, a little bit different. So let's see the first one is fast machine with setup, and second machine is slow machine with setup. And in this first machine, the natural side working time is 1, and the variability of working time is very low, 0.25. And there is a setup, so we need to, the value of NS is 10, TS is 2, CS is 0.25. And in case of second machine, it is slow. So T0 is 1.2. And in this case, this second machine has a little bit higher variability of working time, twice, 0.5. So when in previous example, in this example, there is no information about the working time variability. So we can simply say that second machine is, first machine is better because the production capacity is the same, but the first machine has no variability impact. So in this case, we can easily choose the first machine is better. However, in this case, even though the first machine has a setup process, but the lower level of variability of working time. So now we have to calculate in order to compare which is the better. Better means that low variability. So let's calculate. The CE is very easy because it is C0 equal 0.25. But in case of first machine, a little bit complex, require a little bit complex calculation. So I'll give you 5 minutes with this data, and by use of this formula, please calculate. And please calculate. what is the CE of first machine? I will open the chatting window and I want to know who is the first one, first student who answer and who correctly calculate. 영희나 보지만 말고 손으로 계산하라고. 손으로 계산하세요. Please calculate by hand. 동원이는 팩토리 피직스 책 열지 말고 정곡을 찔렸어? 내 말이 맞나 보네. It's not difficult, but a little bit tricky. So, 동훈아 뭐해? 계산하려니까 보고만 있어. 여인창 학생도 해보세요, 손으로. 그렇게 어려운 건 아닌데. 미니루전 0.28 나오나요? 이게
이게 뭐 급하게 하느라 계산이 틀렸을 수는 있을 것 같습니다.
제가 솔직하게 얘기할게요. 이거 한국 친구들한테 이게 자 답은 0.31입니다. The answer is 0.31. 근데 저도 이게 저도 처음 했을 때 0.29도 나오고 0.26도 나오고 되게 별것도 아닌 계산이 자 한번 who is the anyone finish the calculation? Please typing the final value in the chatting window because actually the correct not correct this answer in the textbook is 0.31 and my calculation just previously the result is the 1.3106763 etc. So I still didn't know why the first calculation result was the 0.29. But anyway, 동훈아 너 얼마 나왔어 너는? 안 했지?
저 아직
너
하고
안
있습니다.
했고. 서연이는? 서연이도 딴
저
거 하고 있어.
방금 그 류철우 교수님이 답장을 해주셔서 그거 확인하고 있어요.
영민아 얼마 나왔니?
저는 0.297이 나왔습니다.
어?
0.297이 나왔습니다.
297이?
네, 297.
297. 그러니까 나도 처음에 0.29가 나왔단 말이지. 저 기영이는 안 돼. 마이크 꺼져 있어.
아직 계산 중입니다.
계산 중이야. 여인창 학생 계산해 봤어요?
저 0.357 나왔습니다.
357?
네.
또 더 이상한 거 없이네.
아마 계산을 잘못한 거.
자, 이게 정말 별것도 아닌데 되게 이상해요. 이게 사람마다 다르고 계산할 때마다 달라지고 이게 무슨 마법의 식인지. 자, 이거는 여러분들 please calculate after the class very carefully and check the final result. Is that the same with 0.31 or still your result in case Samuel's answer is 0.36, so I still embraced about the result. So anyway, the last calculation was 0.31, and the answer in textbook is also 0.31. So please calculate again after the class. It's very, very embracive. Okay, it's the very simple homework. Anyway, the result is this one by now. So the CE square is bigger than so still the flexible machine has a little the lower variability. But if this is changed to 5, it means that if more frequent preemptive, the more frequent the preventive maintenance or more frequent setups, then this will be changed. For your information, the CE square, when the setup period is 5, in that case, is like this. This means that in the case of with the lower number of the setup period makes the machine better. Better means that the lower variability. And in this case, if with the adoption of a faster machine and in operation perspective, the more frequent setup changes makes the machine better compared with the flexible machine. So this is very good insight when design the production process. So this is the result of the non-preemptive outage. So in previous lecture and today's lecture, we have studied the preemptive and today non-preemptive outage. And also we have compared the result of the various kinds of cases. Through those analysis, now we know that the frequent and short repair time is the better case compared with long and infrequent the breakdown. Also, today's the topics of non-preemptive outage, the flexible machine is almost the better compared with the machines with setups. However, in operation terms, the setup, the strategy is enhanced. Enhanced means the reduce the period number. In that case, the machine with setup can surpass the slow machine, the flexible machines. Okay, now we have about 15 minutes, so let's go into the next topics. Next topic is the flow variability. Until now, we have studied only one machine, single machine. And with this single machine, we have studied, analyzed the impact of the variability. And from now on, we are going to the flow variability by considering the connected process. So let's call this machine I, and let's call this machine I plus 1. So there will be various kinds of parameters related with these two. First, this machine have bottleneck ratio, right, like this, and also like this. Also, each machine may have their own variability. like this. And actually, the starting point of flow analysis is arrival of jobs. So we define the arrival rate as RA. Also, this arrival rate have its own variability CA. And also, second machine has its own arrival rate with the variability like this. But in this case, both machine has their own output. So additionally, we have to define this output ratio. And we call this output as departure. So the output ratio RD is like this. Also, this has its own variability CD. And in the same way, okay, these are all required parameters in order to analyze the flow variability. And there is a very important consideration of each machine. It means that the relation between this RA and RE. In order not to explosive, this RE have to be bigger than RA. This is prerequisite condition in the flow variability analysis. Of course, there can be a case of the RA is bigger than RE, but that case will be treated in different way. So in this lecture, we will keep this condition at all the machines. RE is always bigger than RA. Okay. Let's keep in mind this is very important assumption. Now, we need to, also there is one more thing. Actually, this is more important. That is, when we design any production system, there is always the final quantity, there is throughput of this entire system. And in most cases, this throughput will be given. It's not the design parameter. This is the given parameter for the design of the production system. And with this condition, throughput, the arrival rate of first stage have to be equal with throughput. It means that this arrival rate will be same with throughput. This is very, very important assumption that we have to follow. So let's keep in mind these two assumptions. Okay, with this system and also with together with these two assumptions, now we have to induce the flow variability from the preceding machine to the following machine. The first, the constraint of this system is that the YSTD, this departure will be same with this arrival. So first condition is here. RD of I will be equal to arrival of next process. Also, even the CV of both arrival and departure will have to be same in order to seamlessly flow. So now we need to calculate this with the function of the CA and TE. We have to calculate this value with this variability and this working rate. This is the next mission. So let's check the case of the two extreme cases. If the first case, if the we have to reuse this part. If UI is close to 1, it means that 100% utilization, then the machine is almost in working status. In this case, RD is dependent on TE because the motion is always working. So not TD, RE. Also, because this RD is almost the same with RE, so it follows the CD, also follows the CE. This is the first extreme case. And second extreme case is the if UI increase to close to 0%, then the motion is almost in ideal state. Ideal state. So let's highlight this. So in this case, the RD follows the RA because if the utilization is almost 0, but this even though that case exists, this drop have to flow along the process. So in this case, this departure rate is dependent on the arrival rate. Also, in the same way, the CV of departure may be dependent on CA. So let's simply write both cases. Please remember, this is not the exact induction of formula, but this is very intuitive process of the targeting this formula. It means that we have to calculate, we have to know the CV of departure, these terms, and we have to the function, then define this departure CV with the already known parameters of this machine. So with these two intuition, and by combining these two, we can induce CD is this and this plus when this is the closed to the idle state, and this will be dependent on to arrival rate. And all the terms have the square parameter. So this is the final result of the relation of the two connected motions with the flow, the jobs flow. And from this, this is the formula in case of the m equal 1. That is, that means that if this process have only one motion, in that case, this formula can be drawn. And if we refer the factory physics textbook, if m is bigger than 1, means that 2 machines or 3 machines, etc. At that case, this is become more complex. And this is the academic paper that was written by Buzakot and Transiku. Actually, this formula is the result of the research work. And if we insert m equal 1, then this formula is becoming same with this one. Now we can calculate the CD of any system by use of these two formula, even including the case of the motion number is bigger than 1.